Welcome to the 2025 April Tornado Outlook, brought to you by Critical Synoptic Solutions. I'm Kyle Cockson, and in this forecast, we'll break down the key atmospheric signals, historical trends, and what they mean for tornado potential heading into April. Historically, April marks a major uptick in tornado activity across the United States, especially in the southern plains and deep south. States like Texas, Alabama, and Mississippi consistently rank near the top, with Texas averaging about 25 tornadoes and Alabama and Mississippi each averaging 16. This historical backdrop sets the stage for understanding where April tornadoes typically occur and where we should focus our attention when atmospheric conditions align. Large-scale climate patterns like ENSO, the El Niño Southern Oscillation, play a critical role in shaping tornado season. In April 2002, we experienced a transition from a strong El Niño to ENSO neutral following a multi-year La Niña. Tornado activity that year was widespread, stretching from the southern plains into the Midwest. Now, in 2025, we're seeing a similar transition coming off a strong El Niño, briefly dipping toward weak La Niña, and now trending back to neutral conditions. By comparing these patterns and past events to current sea surface temperature trends, we can better assess tornado potential in the coming weeks. Let's take a closer look at the atmospheric oscillations shaping tornado risk as we enter April 2025. Currently, the Northern Atlantic Oscillation, or NAO, is positive and is expected to remain slightly positive into early April, before trending slightly negative by mid-month. This transition could support increased troughing and jet stream dynamics, particularly in the central and eastern United States, raising tornado potential as we move through the month. The Arctic Oscillation, or AO, is also positive, and it is forecast to remain slightly positive into early April, eventually trending toward neutral or slightly positive by mid-month. This configuration generally limits cold air intrusions, but strong upper-level winds can still enhance severe weather risk when paired with adequate moisture. The Pacific North American pattern, or PNA, is currently negative and is projected to remain negative into early April, then trend neutral by mid-month. A negative PNA supports western U.S. troughing, which can dive into the plains and Midwest, maintaining an active storm track. Finally, the Madden-Julian Oscillation, or MJO, is a crucial factor in determining Gulf moisture return and atmospheric instability. Phases 6 through 8 tend to enhance Gulf moisture advection into the central U.S., promoting increased instability and tornado potential. The projected MJO phases for early to mid-April align with these favorable conditions, indicating a heightened risk for severe weather outbreaks. Together, these oscillations and the MJO phase progression suggest a pattern supportive of tornado development, especially by mid to late April. Staying weather aware of these oscillations trend will be crucial as we move deeper into the month. Here's a deeper look at how each of these oscillations impact tornado risk. A positive NAO generally supports zonal flow and reduces cold air intrusions, lowering tornado risk. However, as it trends negative later in April, it could increase troughing and severe weather potential. The AO remaining slightly positive through early April keeps cold air locked to the north, reducing the risk of cold air outbreaks. However, the strong upper-level winds associated with a positive AO can still enhance storm organization when moisture is sufficient. The PNA, currently negative, promotes western troughing and helps steer storm systems into the plains and Midwest. As it trends towards neutral, the influence of the trough may lessen, but the storm track is likely to remain active. Lastly, the MJO phases 6 through 8 favor enhanced Gulf moisture return, which primes the central United States for tornado development. On the other hand, MJO phases 1 through 3 are generally associated with reduced convection and lower tornado potential. Monitoring which phase the MJO settles into will give us more clarity on the evolving risk. The temperature and precipitation outlook for April 2025 points to conditions that could amplify tornado risk. Above normal temperatures are expected from the southern plains to the northeast, fostering increased instability and severe weather potential. Above normal precipitation is projected for the Midwest and Ohio Valley, while parts of the southern plains and southwest remain drier, limiting moisture availability for storms in those areas. However, the 6 to 10 day outlook shows continued warmth and moisture across the southeast and southern U.S., favoring early April storm development. These combined factors suggest that tornado potential could increase early in the month, especially if moisture and upper level support remain in place. In early April, a strong southward dipping jet stream across the plains and Midwest will enhance large-scale lift, increasing tornado potential. Enhanced mid to upper level wind shear will support storm organization and longevity, raising the risk of supercells and severe weather outbreaks. However, model guidance suggests that while the persistent and amplified jet stream supports early April storm development, this pattern may weaken mid-month before potentially re-amplifying later in April. Signals also indicate an active severe weather period in early April, followed by a potential lull as atmospheric patterns evolve before ramping up again later in the month. Early April tornado potential is highest across the southern plains and Midwest, where favorable Cape and shear overlap enhances storm organization. As Gulf moisture increases, instability could expand further north, increasing the severe weather threat into the upper Midwest and Ohio Valley. High shear values support organized storm structures, but storm coverage and intensity will ultimately depend on available forcing mechanisms. Historically, Texas, Oklahoma, Kansas, Illinois, Alabama, and Missouri rank highest in April tornado frequency, with Texas leading at 1,420 tornadoes. April tornadoes are more frequent across the southern plains, deep south, and Midwest, where warm Gulf moisture interacts with strong jet stream dynamics. Tracks of EF3 to EF5 tornadoes from April 1950 to 2014 show the highest impact storms concentrated in the southeast, southern plains, and Midwest. This historical trend raises concerns for April if similar atmospheric patterns develop. April 2002 serves as a strong analog year for April 2025 due to pattern similarities and MJO phase alignment, despite differences in the ENSO evolution. During April 2002, tornado activity occurred from the southern plains to the Midwest and Northeast, driven by favorable jet stream positioning and strong Gulf moisture return. MJO phases 6 to 8 were dominant, promoting increased instability and tornado potential. A negative PNA and slightly negative AO supported western U.S. troughing, creating an active severe weather setup across the central and eastern U.S. April 2002 shows similar atmospheric patterns to what's expected in April 2025, despite differences in ENSO evolution. Widespread tornado outbreaks occurred from the plains to the Midwest and Northeast, driven by strong moisture and jet dynamics. April 2025 could see an above-average tornado season if similar patterns develop. Another important analog year to consider is April 1983. The ENSO evolution at that time transitioned from a strong El Niño to ENSO neutral, followed by a brief, weak La Niña before returning to neutral conditions. This pattern is remarkably similar to the ENSO evolution leading into April 2025. During April 1983, tornado activity was concentrated in the central and southern plains, extending into the Midwest, driven by strong Gulf moisture return and amplified upper-level dynamics. An amplified subtropical jet stream combined with the dominant MJO phases 6 and 7 increased instability and storm organization across the central U.S. Teleconnections, including a negative to neutral PNA and slightly negative AO, supported western U.S. troughing, creating an active severe weather setup in the central and eastern U.S. April 1983 shares key atmospheric and jet stream patterns with April 2025, despite differences in the ENSO evolution path. Active severe weather and tornado potential are likely if similar dynamics and moisture return patterns develop. MJO phases 6 to 7 and favorable teleconnections may enhance instability and support severe weather outbreaks. This forecast highlights areas of increased tornado potential based on historical trends and atmospheric conditions expected in April. The high-risk zone includes Arkansas, Kansas, Missouri, and Oklahoma, where greatest tornado potential exists, including strong or long-track tornadoes. The medium risk zone covers Alabama, Illinois, Indiana, Iowa, Kentucky, Louisiana, Mississippi, Nebraska, Tennessee, and Texas, where an increased tornado threat is expected with some strong tornadoes possible. The slight risk zone encompasses parts of the upper Midwest, Great Lakes, and southern Appalachians, where isolated tornadoes are possible given favorable conditions. Neutral ENSO with a slightly positive AO, slightly negative NAO, and neutral PNA support a severe weather risk across the Southern Plains, Midwest, and Dixie Alley. Historical trends and atmospheric setup indicate an increased tornado risk in the outlying regions. Forecast confidence is moderate to high, but trends may shift as we move into April. Stay informed and prepared by reviewing your severe weather safety plans and having multiple ways to receive warnings, such as NOAA radio and apps. What are your thoughts on the April 2025 tornado season? Drop your thoughts in the comments below. Thank you for watching, and I'll see you in the next video.